college algebra, section 6.7, graphs of inequalities. Some of this will be very familiar to you and some of it will not. So let's take a look. I'm going to start you off with kind of some notes. There are different ways you can do this. This is my preferred method. If you don't like it, Google it and find another. To graph inequalities, first you write the inequality as an equation by replacing the inequality symbol with an equal sign. Graph the resulting equation to establish what we call a boundary line. If the inequality is strictly less than or strictly greater than, draw a dashed or dotted line. But if the inequality is less than or equal to or greater than or equal to, your boundary line should be solid. Then, if the y variable is by itself, is already isolated, you can figure out the shading without testing a point. You simply shade above the boundary line if the inequality is greater than or equal to, and below if it's y less than or equal to. But it's important to note at this point that that only works if y is by itself. If y is not by itself, you must select a test point, a point that is not on the boundary, and substitute the coordinates of the test point into the inequality to determine where to shade. Shade the region where the test point is located if it makes the inequality true, or shade the region that doesn't contain the test point if it makes the inequality false. In other words, shade where it's true, don't shade where it's false. So that's what you have to do if y is not by itself. You have to use a test point. Now, some instructors insist that you do every problem with a test point. To me, it doesn't seem worth it because it takes more time. And so part of the goal here is to make this a little faster for you. So if y is by itself, you can take that shortcut, and you can usually tell just by looking. But if y is not by itself, you have to choose a test point. A lot of people go wrong there, so make sure you don't make that mistake. If you're unsure, pick a test point anyway. For our first example, we'd like to graph the inequality 2x minus 3y is less than or equal to 6. And the first thing we need to decide is, do we want to graph it by getting y by itself, or do we want to just graph it by making a table?
Y by itself.
You want to get y by itself? If we make a table, we can still graph it because it's just what shape, you guys? It's a line, right? It's just a line. You can look at the equation and tell that it's linear. So it's just a line. But we don't know whether to shade above or below because y is not by itself. So if we make a table, we have to do a test point. So it's kind of up to you. It doesn't matter. You can decide. I'm going to go ahead and get y by itself. If I move the 2x to the other side, I get negative 3y is less than or equal to negative 2x plus 6. And when I divide by negative 3, what has to happen?
Flip the signs.
Yeah, instead of less than or equal to, it becomes greater than or equal to positive 2/3 x minus 2. So this is the equivalent, and that's kind of what I want to graph. That's what you want to graph right there. That can be done very, very quickly because it is a line in slope-intercept form. Any questions so far?
I thought you had changed to an equal sign.
We are to graph it.
Okay.
But I just wanted to get y by itself first.
Okay.
Okay, so now we want to think about how would I graph it if it were y equals.
How the y-intercept.
Yeah, you would just put a dot at the y-intercept, and then you would count the slope of positive 2/3. So put a dot at the y-intercept, negative 2, and count a slope of positive 2 over 3, rise over run. If you want to come back this way. But before you connect those dots, you need to decide, should that line be solid or dotted? How do we know that it's solid?
Or equal to.
Because it's
Greater.
equal to. It's that symbol right there, that line underneath it, that tells us it's solid. So we connect that with a solid boundary. In this case, it's a line. And then we have to decide whether to shade above or below the line. And if you're not sure, you can plug a test point into the original to see if it makes it true or false. But because y is by itself and it's greater than, not less than, we shade above. So we shade everything above the line. So if you put your pencil here you look above, we're going to shade on this side that's up above there. So all of this should be shaded. And I'm not a very good shader. I never have been. I was never good at coloring either. I don't particularly care for it. How's that? Is that okay? So what that means, you guys, so we were able to figure out which way to shade because we were able to isolate y. And because it was greater than, in this case greater than or equal to, we knew to shade above. But if you weren't sure, you could pick a test point as long as it wasn't on the line. So like I could pick, for example, 0, 0, and I could substitute it into the original. So I'm going to pick 0, 0 as my test point just to show you. 2 times 0 minus 3 times 0 is less than or equal to 6, which is 0 minus 0, so 0 is less than or equal to 6. Is that true or false?
True.
It's true, which means I should shade it on that side. And sure enough, we can see that I'm shaded over there where that test point is. If it made it false, I would shade on the other side. So that's how you can pick a point and test it. If I picked the point 5, negative 2, 1, 2, 3, 4, 5, negative 2, and I substitute that into the original, should that make it true or false? False, because it's in the unshaded area. So we could check that one. 2 times 5 is 10, and negative 3 times negative 2 is positive 6. And we can look at that and see that 16 is not less than or equal to 6. It's false. So if you're unsure where to shade, just plug points in and see if it makes it true or false. Shade where it's true, not where it's false. So that's example 1. I'm going to pause for a second and see if you guys could graph this one. The nice thing about this is y is already by itself. But be careful because it's no longer has an equal to with it, it's strictly less than. So y is less than 2x. So for this example, we see that y is already by itself. And so we know that it's going to be dashed or dotted because there is no equal to line underneath it, and that it's going to be shaded below. So now I can just graph the line y equals 2x. So you kind of graph it and pretend like it's not an inequality. If it were an equal sign, what would the graph look like? It would just be a line with positive slope with a y-intercept where?
0.
At 0, and a slope of positive 2 over 1. We will make that dashed, and I will shade everything below that dashed boundary line. So if I put my pencil on that line and I drop below, I'm down in this area here. So that's the area that I want to shade. It's everything below it. And if you're not sure, you could pick a point and test it to make sure it makes it true. So for example, I could pick the point 5, 0 and plug it in. Would that be okay? Let's test it just to make sure we've got it right. So if I want to test the point 5, 0. 1, 2, 3, 4, 5. That's over in the shaded area, so that should make it true. So if x is 5 and y is 0, I have 0 is less than 2 times 5. 0 is less than 10. True or false? That's true. So it should be shaded there. Any questions about graphing linear inequalities?
What if you got a line that's just straight up and down?
If the line is vertical, instead of shading up or down, you shade left or right. So if you imagined like a vertical line, say it was right there, which side of that line would be bigger? To the right or to the left?
Right.
To the right, yeah. So you would shade right if it were greater,
Okay.
and you would shade left if it were less than.
Because it's like infinity.
Yeah, so you just think about it that way. Most of the time it's up or down, but if it is vertical, it becomes a left-right situation. And if you're not sure, just pick a test point.
Okay.
Okay. So this is the first one we're going to look at where the inequality is non-linear. So we have the equation x squared plus y is less than or equal to 36. Well, here the situation is a lot different because it's not linear. What shape is that? If it were just x squared plus y equals 36, what shape would that be? Does anyone remember? Anyone remember?
It's a.
If the x and the y are squared,
Ellipse. Circle.
it's a circle. If the x, you're trying them all of your conic sections. If the x and the y are squared with a plus sign in between them and the same coefficient, a 1, then you're dealing with a circle. Okay, so this is something we definitely need to review because I can tell it's kind of slipped some of our minds. The equation of a circle is x minus h squared plus y minus k squared equals the radius squared. So if you remember that. Now, if the circle is centered at 0, 0, those parentheses disappear. And that's what's happening for the circle we have here. Its center is at 0, 0. What's its radius?
Yeah, 6.
And its radius is 6. We know because it's the square root of the 36 there. That's all we know so far. Can I easily get y by itself?
Square.
I mean, I could. I would have to move the x squared. I'd have to take the square root of both sides. I'd have to do a plus and a minus. So to me, it seems like it would be a whole lot harder to graph it if I got y by itself. So this is one of these cases, if it's not easy to get y by itself, you're probably better off not doing it. So if it's not linear, chances are good, you should just leave the y alone and just graph it and then do a test point. So I need to decide whether it's solid or dotted.
Solid.
Solid. Okay, so if I graph a solid circle centered at 0, 0 with a radius of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And I make that circular. And mine's not really a circle, it's more like an egg, but that's okay. It's even worse down here. Some days are better than others. Wow, this is a special little circle. Okay.
The left side it looks. Yeah. The right side
Left
is
side
a
is
triangle.
Well, anyway, I need to decide whether to shade inside that circle or outside the circle. And since we can't easily get y by itself, the best thing to do is just to test a point. You can pick any point. I usually pick a point inside the circle.
1, 1.
So we could do 1, 1. Could you test the center?
Yeah.
Yeah, you could test the center. So you could use 0, 0, or you could use 1, 1. It doesn't really matter. Let's just test 1, 1. If I test the point 1, 1, and I substitute into the original, I get 1 squared plus 1 squared is less than or equal to 36. So is this true or false? It's true. So that means I should shade where? Inside. If it were false, I would shade outside. So this was my test point, and since it made it true, we want to shade inside there. And I've told you before that I'm not a very good shader. So. I'm also not a very good circle drawer, apparently. Okay, so if I picked a point outside the circle and substituted it in, would that make it true or false? False. It would make it false. So we kind of understand what's going on here and how to check them and all of that good stuff. Any questions about the circle problem? All right, that's a good spot for us to stop and cut the video.